Good morning, good afternoon, good evening, whatever the case may be. We are back in better than ever. Graphing quadratic functions part 2. Let's get right to it, shall we? Let's shall. Okay, so given or based on the graph of y equals x squared, we are going to graph these guys, okay? So based on our previous experience for A here, we should recognize that we are going to have a horizontal shift of +2 and a vertical shift of +3. So that should be pretty easy to graph. Remember, within the parentheses, because the general form is y equals x minus h, the quantity squared, plus k, then that is our shift. So let's just do the easiest thing, the vertex. We're going to go move it to the right 2 units, 1, 2, and then up 3 units, 1, 2, 3. There we go. And what are the coordinates of that? 2, 3, right? We went right 2 and up 3. That's the coordinates. Hey, that's the coordinates of our new vertex. So we have learned something, boys and girls, that HK, when we're in this form, is our vertex. In fact, this is called vertex form. Okay, so we have that, right? You could also, you know that 1, 1 is a point, like right here, if you wanted to, you could move that to the right 2, and that up 3, and then you have that point. So you know you also have, with an axis of symmetry, the axis of symmetry is always going to fall through or go through the vertex right there. Then you also know that you have the mirror image right there, and you can sketch your parabola. You can also easily get the y-intercept. That's not it, actually. You can let x equal 0, right? -2 squared is 4, plus 3 is 7, so 1, 2, 3, 4, 5, 6, 7. So you have a lot of points to sketch a nice, smooth curve of y equals x minus 2, the quantity squared, plus 3. So here we're going to have a horizontal shift of -2, -5, which is actually our new vertex. So this is 1, 2, we got to go down a little further, right? So that's -3, -4. We'll make that -5 all the way down to the bottom. So my new vertex, HK, is -2, -5. Down, left 2, down 5. There we go. And then we have our axis of symmetry. So I know we got a point here and a point here. Maybe I want my y-intercept. Let's see. 0 plus 2, so 2 squared is 4, minus 5 is -1. So there's my y-intercept. And I've got a nice little sketch here of my parabola, something like that. All from y equals x squared. Great strategy in sketching quadratics. We can also, in order to get it in the form y equals x minus h squared plus k, we can complete the square. Oh, how nice! If we don't want to deal with like plotting points with this and what the middle term does, all we have to do is complete the square. All right, so let's do a couple of those, or just one actually. So we're going to rewrite this as y equals x squared plus 2x. Well, it is x squared plus 2x plus 5. Okay, so we are going to complete the square on that. Now, how do you do that? Very simple, very easy. I still do the same thing. Y equals x squared plus 2x. Don't forget about the 5. We're not going to move it over because we have the y there. We're just going to keep it in our back pocket for just a second. I'm going to take half of 2, which is 1, and square it, and then add 1, right? Okay, and then I still have my plus 5. But this is not the same as this. What has changed from here to here. What has changed? Well, we have added 1. So to compensate for that, I'm also going to subtract 1, because 1 minus 1 is 0, which is now equivalent to that. Why would I do that? Well, now I can write these 3 terms as x plus 1, the quantity squared, and then 5 minus 1 is 4. Giddy up. So I am in the form of y equals x minus h squared plus k. So I immediately know that this is a translation of y equals x squared of negative 1, 4. And I also know that my vertex is negative 1, 4. Isn't that just grand? Okay, so we are going to sketch that real quick. Let's put our axes right here. And we know that our vertex is at negative 1, 1, 2, 3, 4, right? And so what's our y-intercept? 0 here. Let x be equal to 0. 1 squared is 1 plus 4 is 5. So that's 1, 2, 3, 4, 5 right there. We have this, and we can do a nice little sketch of that curve. It is so simple. They want us to state the coordinates of the vertex, which we did down here, but we'll go ahead and label the vertex. There we go. Could it be any easier? I don't know. All right, so what happens if I have a coefficient other than 1? Well, y equals 3x squared. That is, since it's not a fraction where the numerator is less than the denominator, this is going to make it a heck of a lot steeper. Okay, it's going to stretch it up, make it narrower. Well, 0, 0 isn't going to change because 0 squared is 3 times 0 squared is 0. But what about 1? Okay, this is the easiest thing to do, is the 1, right? Well, if x is 1, 1 squared is 1 times 3 is 3, so instead of 1, 1, I have 1, 3, 1, 2, 3. And I have its mirror image. That is enough to sketch this. That's all we really need, yes? You could do a couple other points, just makes it thinner. And then negative, well, it's the same thing, right? It's just flips over the y-axis. The negation makes it open downwards. And notice I went down to negative 3, 1, negative 3, negative 1, negative 3. And there we go. Okay? No big deal. Okay. Sketch the graph from the graph of y equals x squared and state the coordinates of the vertex. Well, there's y equals x squared. So I know that my vertex, well, I know it's going to open downward, right? I know that. And I know that my vertex is at 2, negative 3. Yes? 2, negative 3. So that's 1, 2, 1, 2, 3. It's right here. Okay. I can get my y-intercept. Let's see. 4 minus 3. I forgot the negative there. The negative out in front. So 0 here, negative 2 squared is 4, but this negative is out in front. So negative 4 minus 3 is negative 7. 1, 2, 3, 4, 5, 6, 7. That's really all you need because this is 2 away. So if I know my axis of symmetry goes through the vertex. So if I go 2 more over this way, I've got 3 nice points. And I can sketch that vertex. Every point here is a mirror image of the point here. So that's how I got, once I got my y-intercept, which is 1, 2 units away from the axis of symmetry, I know this is also 2 units, and I can sketch my parabola. Okay, last, just a summary here. You might want to pause it and go through this. If we look at this function, and here's the graph, right, this quadratic function. Here's the graph of y equals 3x squared, and then here's the graph of y equals 3 times x minus 1, the quantity squared, plus 2. This graph has the same shape as 3x squared. It's just translated with a vertex of 1, 2. And we can show, if we on expanding, we get y equals 3x squared minus 6x plus 5. So here's the big summary here. The graph of a quadratic function of the form y equals ax squared plus bx plus c has the same shape as the graph of y equals ax squared. Okay, good lesson there. Hope you enjoyed everything. I know I certainly did. And with that, I'm going to say, let's listen in a little bit more on the wonder wall, because quadratic functions, let's face it, those are wonder walls. And with that, I'm going to say, I am out.